Okay, now let's do an example, but now we're going to introduce, so now this is a new subsection. So we've done a lot of work in the last subsections and sections dealing with these relationships with vector spaces, talking about bases and mapping and all of these different things. And then we introduced the connection between those mappings and being onto one-to-one and with matrices, right? So we've made those connections of those. Now we're going to turn our attention to the actual operations, matrix operations, and how we can use those to actually determine certain things. Okay, so now we're going to start, our next subject is going to be all about matrix operations, and so this first part is all sums and scalar products. Okay, so that's what we're going to talk about. And so we're going to introduce by using an example. So in this example, we have a function, a mapping from vector space v to w. Let that be a linear function with respect to some bases by this matrix. So here's our representation matrix, right? So we're going to use 1, 0, 1, 1. And now we're going to consider the map that is a scalar multiple. So we're going to call that 5f. Okay? So it also maps from v to w. And what we will do is we're going to relate the representation of this, right, with this. Okay? So which we have. Okay? So now what we're going to do is let's f associate v to w with these representations. So here's representation with respect to b. It's going to be this vector, v1, v2. And this representation with respect to the basis d is going to be w1, w2. Okay? Now here's a basis. Let's let d be this basis here. We'll fix that at delta 1, delta 2. And so that w, the vector w, is going to equal this linear combination of the basis vectors. Okay, and so that's where we're at right here. And then the action, now here's the action of the map for 5f is this. So we're basically, again, it's a scalar multiple. So what does that mean? It means that 5w is going to be equal to this. So we're just substituting in our linear combination. And then we're going to use the distribution. And so we end up with this linear combination. Okay, now, from here, we see that 5f associates the input vector v with the output vector having this representation. Right? So let's do this. Let me erase some of this here. I don't want to erase it all. But let's give myself some room here. Okay, so now we're going to use this representation for the output vector. So the output vector which is 5w, is now given by this. Okay. Now, changing from the map f to the map 5f has the effect on the representation of the output vector by multiplying each entry by 5. Now, because of that, our representation matrix for 5f is going to be this. Okay. Oops. Yeah, that's right. Okay, so now what we're going to do is notice how this is now going to be 5 V1. And this one's going to be 5 V1 plus V2. Okay, now remember, okay, so there's our representation matrix. Okay, oh, that's not right. There we go. And then what does that give us? Well, here's our F, so that gives us from this our representative matrix with respect to B and D of 5F is equal to what? So therefore, going from the matrix representation F to the one representing 5F means that we're just multiplying all the matrix entries by 5. And maybe that's what we were intuitively, maybe you thought that that was intuitive, and maybe that's not a surprise, but that's important. Okay? And so we're going to move on.